Welcome to the Big Bear Math channel and our second 5-minute video on integration by U-substitution. Now, because U-sub is such a broad topic, we've broken it into 3 specific categories that you'll see on the AP exam. So in the next 5 minutes, over the course of these 3 videos, we're going to show you exactly what you need to do to go get a 5 on the AP Calculus exam. So it's a bear of a course, and it's time for us to go tackle some bears. So here's a brief overview of those 3 different scenarios that you'll see on the AP exam. Category number 1, we talked about identifying the inner function and then letting U equal that inner function. So we covered that in our first video, and if you didn't watch that one first, I encourage you to go back and take the 4 or 5 minutes to watch that one before you dive into this current one. So number 2, this is the one we're going to tackle tonight, and this is where we say if you see a fraction, there's probably a 99% chance that you're going to want to let U equal the denominator, and so that's our golden rule in this video series. And then in the third video, we'll talk about letting U equal the exponent. So here's a brief warm-up though before we actually dive into the actual U-sub. I want you to recall back in your derivative days, if you wanted to derive a natural log function, and maybe it was the natural log of U, and what we'll do for the sake of this discussion is we're going to assume that U represents some function of x. It could be anything that's in terms of x. And so the derivative was, we said we're going to derive U and then divide by U, and that was your derivative. Well, remember, integration is the inverse of derivatives, and so we're going to reverse that process today, and we're going to integrate du over u, and we're going to say that the antiderivative is going to take us back to the natural log of the absolute value of u, and then of course we'll throw in our constant at the end. So we're basically just reversing this process. So maybe they gave you the function, maybe the natural log of x cubed plus 2. And we said, well, his derivative is going to be 3x squared divided by x cubed plus 2. Well, today we're going to reverse that process, and we're going to say, well, if they want us to integrate 3x squared over x cubed plus 2 with respect to x, then the antiderivative is going to be the natural log of the absolute values of x cubed plus 2 plus c. And so the last couple minutes of this video is all going to be about how to get from here to here. So here's our first live example, and our theme today is integrating that fraction and letting u equal the denominator. But a real quick overview in the same statement we made in the last video, our main goal is to rewrite the entire integral in terms of u. In other words, we want to get rid of all of those x's, and that statement's going to hold true for all 3 of these videos as we try to really master U-sub. So without further ado, here's my denominator today. So I'm going to let u equal 6 minus x cubed. I'm going to derive both sides with respect to x. So du, the derivative of u with respect to x, equals negative 3x squared. Now I'm going to solve for dx. I want to try to get that dx by itself. So I'm going to multiply it to the other side. Du equals negative 3x squared times dx. And once you practice a lot of these u-subs, you'll be able to go really fast with this process and then just divide the negative 3x squared to the other side. So we got the du by itself. Now it's time to make all my substitutions. So here's what's happening. I'm going to substitute the u in for the denominator, and then I'm going to substitute du over negative 3x squared in for my dx. So here's what it'll look like once I make that substitution. I still have 4x squared as my numerator. My denominator now is just u, and then where I had the dx, I'm now going to put du over negative 3x squared. So a lot of times the most challenging part is just getting the right coefficient and staying organized. The greatest thing happening here is that those x squareds cancel out. And then I'm just going to rewrite it with my coefficient pulled out front. So I've got negative 4/3 as a coefficient, the integral of du divided by u. Now it's perfect. We know that the antiderivative of du over u is going to be the natural log function. So we've set ourselves up really nice. Again, emphasis on getting rid of all of the x's. So I carry my coefficient down. The antiderivative is the natural log of the absolute value of u plus c. And then we're just going to go one iota further, and we're going to rewrite it in terms of x. So we've got the natural log of 6 minus x cubed plus c. And there you have it. So if you're looking for more examples, feel free to search our channel for more integration by U-Sub.